Imagine you are standing on the shore, looking out at the vast ocean. Who are you in this universe? Where did we come from? And what journey has brought us, as thinking creatures, here to contemplate the grandeur of all things? Join us on the most spectacular adventure of all, the evolution of the universe, life and civilization. A story spanning billions of years with dramatic events that have shaped our very existence. Don't forget to subscribe to the channel so you don't miss out on other exciting space exploration videos. If you find the video interesting and useful, please like and share to support us. Welcome to an incredible journey of discovery into the evolution of the universe, life, and civilization. We will start from the very beginning of it all, the Big Bang, to the birth of thinking societies like ours. About 13.8 billion years ago, our universe began as an infinitely small, hot and dense state, a singularity where all the laws of physics as we know them broke down. This was the Big Bang, an event that was not an explosion in space, but rather the expansion of space itself. Immediately afterward, the universe underwent a period of hyperinflation, expanding at an unprecedented rate, smoothing out any initial inhomogeneities, creating the smooth, uniform universe we observe today. In the first moments of the explosion, the temperature of the universe reached hundreds of billions of degrees. Elementary particles such as quarks, electrons, neutrinos, and their antiparticles were born. The universe was filled with radiation, a primordial hot fireball. As the universe continued to expand, it cooled. About 1/100th of a second after the Big Bang, the temperature dropped to about 100 billion degrees. Quarks bound together to form protons and neutrons. 3 seconds later, the temperature dropped to about 1 billion degrees, hot enough for protons and neutrons to start combining, forming the nuclei of light elements such as deuterium, heavy hydrogen, helium, and lithium. These nuclear fusion reactions continued to rage in the hearts of stars later, but a significant portion of the light elements were already formed in the early universe. About 380,000 years after the Big Bang, the universe continued to cool to the point where electrons could bind to nuclei, forming the first neutral atoms. This event was crucial. Before then, radiation was trapped in a cloud of charged particles, unable to move freely. But when neutral atoms formed, light could escape, making the universe transparent. Radiation from this period, known as the cosmic microwave background, CMB, still exists today, providing compelling evidence for the hot Big Bang model of the universe. After the universe became transparent, matter began to condense under the influence of gravity. Regions with slightly higher density than average began to attract more matter from their surroundings. This process took place slowly over millions of years, leading to the formation of giant clumps of matter, proto-galaxies. Over time, these proto-galaxies continued to collapse and spin faster due to the law of conservation of angular momentum, gradually transforming them into the giant spiral galaxies we see today, with billions of twinkling stars and swirling clouds of gas and dust. In the hearts of newly forming galaxies, smaller clouds of gas and dust continue to collapse under their own gravity. The temperature and pressure inside these clouds increase to the point where hydrogen begins to fuse into helium through thermonuclear reactions. This is the lighting up moment of the first stars. These stars, bright and hot, are the colossal smelters of the universe. They burn their hydrogen fuel, producing energy in the form of light and heat, and fusing heavier elements such as carbon, oxygen, and later silicon and iron. This process takes millions to billions of years, depending on the mass of the star. Massive stars, after exhausting their fuel, end their lives in spectacular explosions called supernovae. These explosions blast the synthesized matter into space, enriching interstellar clouds of gas and dust with heavy elements. These clouds then collapse, forming new generations of stars enriched in heavier elements. Our Sun, a second or third generation star, contains about 2% heavy elements, evidence of the existence of earlier generations of stars. In these clouds of gas and dust, rich in heavy elements, planets began to form. The accretion of matter created rocky planets near the star and gas giants farther out. Our tiny rocky Earth formed about 4.6 billion years ago. Early on, it endured violent impacts from comets and asteroids, leaving countless craters on its surface. However, thanks to an atmosphere and water, these scars have gradually been erased over time. On the young Earth, as conditions became more stable, life began to emerge. About 4 billion years ago, in the primordial lakes and oceans, complex organic molecules formed from simple gases and energy from lightning and ultraviolet radiation. By chance, a rudimentary, self-replicating molecule appeared, the precursor to DNA. This was the beginning of heredity and evolution. Life began as tiny single-celled organisms such as blue-green algae that colonized the oceans for billions of years. Then around 600 million years ago, the Cambrian explosion occurred, with a spectacular increase in diversity and complexity of life forms. From fish, reptiles, dinosaurs to mammals and finally humans, each evolutionary step was a long process of natural selection, where random, beneficial mutations were retained and passed down through the generations. What is amazing is that we, creatures made of stardust, have developed the intelligence to wonder about our origins and the origins of the universe. The emergence of intelligence and civilization is one of the greatest achievements of evolution. Our ancestors, hunter-gatherers living under the starry night sky, began to observe and recognize the laws of nature. They built structures to track the movements of the sun and stars, and from there they predicted seasons and important events. This spurred the development of mathematics, writing, and early astronomy. From Eratosthenes measuring the circumference of the Earth to Copernicus placing the sun at the center, each step forward was a liberation of thought from old prejudices. With the development of telescopes, we discovered distant galaxies and realized that the universe is expanding. Einstein revolutionized our understanding of space and time with his theory of relativity, showing that they are not static but warped by matter and energy. Quantum mechanics revealed the mysteries of the subatomic world, showing that even empty space is full of virtual particles. And black holes, seemingly eternal darkness, emit radiation, slowly evaporating. All these discoveries have completely changed the way we see ourselves and our place in the universe. Today, our civilization is advancing at an unprecedented pace. We use technology to explore other planets, sending unmanned probes to Mars, Jupiter, and Saturn, bringing back incredible images and data. We have come to realize that Earth is a precious, unique home in the vast universe, but also vulnerable to our own actions. The development of technology and intelligence presents us with both an opportunity and a challenge. Will we be wise enough to protect our planet and sustain life to continue our exploration of the universe? Or will we destroy ourselves in the nuclear wars that Carl Sagan warned us about, or change the climate to the point where we cannot survive? We have seen the cosmos's epic journey, from the first moments of the Big Bang through the formation of galaxies and stars to the emergence of life and civilization on Earth. But are we alone in this vast universe? Or are there other civilizations out there among billions of stars also contemplating the heavens, wondering about their existence? In the next episode, we will delve into one of humanity's most daring scientific projects, the SETI project, the hopeful search for intelligent life beyond Earth. Explore the efforts, challenges, and big questions we face in our search for our cosmic brothers and sisters. Don't miss it.